So today we're going to talk about taking the derivative of inverse trig functions. And the first couple slides are kind of reminders about trig functions, so you don't have all of this in your notes. So the inverse trig functions, this is the arc sine or the sine inverse. And remember, we use these to reverse trig. So if I have I want to get an angle measure, this is what I would use the arc sine or to cancel out a sine, basically. So they do have different ranges that they're valid in. We're probably not going to need to get into that today, but just as a reminder that those things exist. And then these are what the pictures look like. If you can envision, remember in inverse, switches the x's and the y values. And if you can kind of envision that this is what a sine function looks like, you can see how it kind of flipped the sine function and across the line y equals x. And then the same with all the others. It's kind of just so you have a general idea of the pictures. And then this is one of the properties that we learned, is that when we have the sine and the arc sine, they cancel each other out to just get the measure that's in there. Same thing the other direction to get whatever's on the inside. And that works for all the trig function, our inverse trig functions. So this is where you need to pause the video and write these down. I'm going to let you go ahead and pause, and then I'll pause for a couple seconds, then I'll start talking again. But please pause and write those down. So we've got the 6 trig functions, just like we know they exist, and we have their derivatives. It's basically a formula. Remember that u prime is just meaning chain rule. So really when I'm looking at arc sine, I'm really looking at 1 over the square root of 1 minus u squared, and then do the chain rule, okay? So you'll notice that the arc sine and the arc cosine, very similar, except that the co, just like any of the cos, has a negative in front of it. Tangent and arc cotangent look the same, and arc secant and arc cosecant look the same. And it's really all about just following the formulas. Typically on the actual AP test, we see these 3 more than we would see the cos. Okay. All right. So find the derivative function, and as always, we do have to take chain rule into account. So I am going to, first of all, put some parentheses around this. And then I notice that I do have a u in there. So that is my u. So I'm going to start with that. U equals 2x, which means that u prime equals 2. So that's the derivative of my inside. My outside is arc sine of u. So I'm going to take the derivative of that. And I need to go back and look at my formula. Okay. Hang on. All right, so when I go back and I look at my formula, I know I'm using this formula. In place of the u prime, I'm putting a 1, because that's what all those really mean, is there's a 1 on the top. So I've got 1 over the square root of 1 minus u squared. So 1 minus u squared. Then I'm going to go ahead and put this together just like I did the rest of my chain rules. So f prime of x equals my official derivative. Oops. The derivative of the inner function, which is 2, times the derivative of the outside function, which is 1 over the square root of 1 minus u squared. Instead of u squared, though, I'm going to go ahead and put my u in, which is 2x squared. And I could leave it like that, or I could rewrite it as 2 over the square root of 1 minus 2x squared. I could rewrite it, I could multiply that out, so you might see 1 over 2, or 2 over square root of 1 minus 4x squared. So again, all 3 of those are really good, valid answers. All right, we're going to try it again. This time I've got arctangent. So, and again, I should have parentheses there, implied parentheses. And I'm going to underline my u. I'm going to definitely have a chain rule. So u equals 3x u prime equals 3. Then I'm going to take my outer function is the arctangent, and I'm going to replace the 3x with a u. So the formula for arctangent says 1 over 1 plus u squared, if I went and I read that, right? You should be reading your formula. So that's the formula right there. All right, so we're following the rules we know. F prime of x equals the inside function, which was derivative of the inside, which is 3, times the derivative of the outside, which is 1 over 1 plus, and instead of writing u squared, I'm going to write 3x squared. I'm going to clean it up a little bit, so it would be 3 over 1 plus 9x squared. All right, example 3. This here would be our u. So u equals the square root of x, or we would say x to the 1/2 power. Okay. So u prime equals 1/2 x to the negative 1/2 power, right? If I subtract 2 over 2 from that, and then we would probably rewrite that as 1 over 2 square root of x, right? It's negative, so we bring it downstairs and put the radical back over the top. Now let's do the derivative of the outside function. So f equals the arc sine of u. We're going to go back up to our formula chart and look, and you will have to have the formula chart memorized. 1 over 1 minus u squared. So double check. Yep, 1 minus u squared. Okay. Let me fix this. Okay, so now we're going to go my official derivative. F prime of x equals the derivative of the inside, which is 1 over 2 square root of x, times the derivative of the outside, which is 1 over, lost my u, 1 minus u squared, and my u is the square root of x. Okay. And then, what did I lost something somewhere. It's the square root over the top of that. That's what I'm missing. I know I was missing something. It's the square root of this. All right, so if I try to simplify that, because say we're going multiple choice, I'd have 2 square root of x times the square root of 1 minus x, because square and square root would cancel. The other, I could leave the answer like that, but the other algebraic piece we might see is because these are both inside the radicals, we may see this x distributed. So it might be 1 over 2 square root of x minus x squared. All right. Let's look at this next one. So, this one here, example 4. So again, I'm going to look for my u, which happens to be this. So we've got that u equals e to the 2x. And before we can take u prime, we notice, there's another chain. So w equals 2x. So w prime equals 2. The outside part of that chain would be f equals e to the u, and the derivative of e to the u is e to the u. So we know that the derivative is the derivative of the inside times the derivative of the outside, but for u, we're going to substitute in 2x. Then I have to finish this chain here. So f equals arc secant of u. So f prime equals, so I'm going to go back and look at my chart, 1 over the absolute value of u times the square root of u squared minus 1. All right, I'm going to write my final answer. So official derivative, f prime of x equals the outside, the derivative of the inside, which is 2e to the 2x, times the derivative of the inside, the outside, 1 over u, which I'm going to rewrite u as e to the 2x, the square root of e to the 2x squared minus 1. Now, if I took the absolute value of this, I would get e to the 2x. So you'll notice that this and this are the same, so we could cancel those. So my final answer would be 2 over the square root of power to a power we multiply, we'd say e to the 4x minus 1. All right, example 5 is a little bit more complicated. We have a fairly straightforward inverse trig, but look at what really we have going on here. Here we have a product rule because I've got a variable times a variable, and this is old stuff, okay? So I'm going to take the derivative of my arcsine first. So derivative of arcsine, if I looked at my chart, is 1 over 1, the square root of 1 minus u squared, which in this case u is x. And I didn't have anything other than an x there, so I'm not doing a chain rule. All right, so now you'll notice on this other part, I've got my red function, I've got my green function. Okay, so I'm going to go ahead and follow my rules. I'm going to take the derivative of my red, which is 1. Keep the green the way it is, 1 minus x squared, plus. Keep the red the way it is. Ooh, now I need the derivative of that green, which is the same as saying 1 minus x squared to the 1/2 power. I know that inside there is a chain rule. So I'm going to do my chain rule off to the side. So u equals 1 minus x squared. U prime would then be negative 2x. And then my outside function is f equals u to the 1/2, u to the 1/2. So f prime equals 1/2 u to the negative 1/2, or 1 over 2 square root of u. All right, so now we're going to write that official derivative, but I'm going to write it up here. So derivative of my inside, which is negative 2x, times the derivative of my outside, which is 1 over 2 square root of the u, which is negative 2x. No, it's not. Sorry, my u, I did the derivative of my u. The u is 1 minus x squared. Ooh, highlighter. 1 minus x squared. All right, and then again, I look for things I could cancel. I could cancel this 2 and that 2. So if I wanted to clean up the back part of that answer, I could do it as 1 over the square root of 1 minus x squared plus the square root of 1 minus x squared plus x times x would be x squared over the square root of 1 minus x squared. And again, hopefully you notice that this and this are common denominators, so I could put those two things over the same common denominator and go 1 plus x squared plus the square root of 1 minus x squared. I could go further with this piece and get a common denominator, but I'm going to choose not to. All right, we got one more with a log and a little bit of a chain rule or two here. So you'll notice that this piece is a u and this piece is a whole another u there. We happen to have t's instead of x's. It's not a big deal. So I'm going to do this u first. So my first u is going to be t squared plus 4. And that's a regular t squared, not a negative one. U prime is going to be 2t. So my outside function is the natural log of u. So f prime is 1 over u. I'm going to start writing my official derivative down low here. So my derivative of my outside is 2t times the derivative of my inside. Sorry, derivative of my inside was 2t. Derivative of my outside is 1 over u, which is the t squared plus 4. And then notice we've got a minus and a 1/2 going on there. All right, so then I've got to deal with my other u, which is this chunk right here is my other u. So u equals, I'm going to rewrite that as 1/2 t. So u prime has got to be just 1/2. And then my f is the arctangent of u, which f prime is 1/1 plus u squared. All right, I'm going to fill in my official derivative here. So I had the 1/2 that was hanging out here in front times the inside function 1/2 times the derivative of the outside, which is 1/1 plus u squared. Instead of u squared, I'm going to write 1/2 t squared. All right, I'm going to choose to go ahead and clean this up just a little bit because you might see it multiple choice. So 2t over t squared plus 4 minus 1/2 times 1/2 would be 1/4 times 1 plus, and if I square that, I get 1/4t squared. The only other thing that they could do with this is distribute this in. So it could look like this, 2t over t squared plus 4 minus 1/4 times 1 is 4. 4 times 1/4 is 1t. We're squaring that whole thing.